Assalamualaikum warahmatullahi wabarakatuh. We are from Group D and today we will be presenting our machine learning assignment 2. First and foremost, my name is Gara binti Rahman Garigo and my matric number is 2216574 and my other group members are Fitra Nur Humaira binti Muhammad Radauddin 2212822 and N.Fatihah Hamzah 2210378. Foremost, let's move on to the dataset that we have chosen. So for this assignment, we have chosen the bird migration dataset that we found from Kaggle. This dataset contains over 10,000 rows and 41 columns. These records simulate the migration behavior of various bird species across different global regions, and each record represents an individual bird tracked using a tagging device and includes features or columns such as flight distance, speed, altitude, weather conditions, tagging details, and migration outcomes. Although the data is artificially generated, it is based on realistic ranges from ornithological research, which makes it ideal for data analysis, machine learning, and visualization tasks. The main reason why we chose this dataset is because it is a multi-dimensional dataset as it has over 30 columns. So for our assignment, we have chosen to use the random forest classifier algorithm as our machine learning model. So the random forest is a machine learning algorithm that builds many decision trees and combines their results to make better predictions. It works by letting each tree vote on the outcome, and the most common vote is chosen. This makes it more accurate and stable than using a single tree. So why did we choose it for our project? We chose random forest classifier because it is highly accurate and works well with complex datasets just like ours, which includes many features such as flight distance, weather, and altitude. It can also handle both numerical and categorical data, and it is resistant to overfitting. It also works well when some data is noisy or less relevant, so it gives us a clear idea of what features are most important for predicting bird migration outcomes.
Assalamualaikum everyone, my name is N.Fatihah, matric number 2210378. I will explain the feature selection and feature extraction technique we use in our project. Feature selection is the process of selecting the most relevant features from a dataset, helping to reduce complexity, speed up training time, and improve model performance. As for the feature selection technique, for the filter method, we use the SelectKBest technique. SelectKBest works by scoring each feature individually using a statistical test. In our case, we use the f_class if function, which is suitable for classification tasks. We set k equals to 20, meaning we wanted the top 20 most relevant features. We apply the fit_transform function to our training data, x_train and y_train to calculate the scores and select the best features. Then, we use the transform function on the test data to ensure only those 20 selected features were used in the final prediction. The method is simple, fast, and helps reduce the dataset size without relying on any specific machine learning model. For the wrapper method, we chose Recursive Feature Elimination or RFE. Unlike filter methods, RFE use a machine learning model to evaluate feature importance. In our case, we use a random forest classifier with 100 estimators and fixed random state for reproducibility. We told RFE to select the top 20 features. It trained the model, ranked the features by importance, and removed the least useful one by one. Again, we use fit_transform on the training data and transform on the test data to keep everything consistent. The advantage of RFE is that it directly considers the performance of the model while selecting features, which often leads to better results. Moving on the feature extraction technique, we apply principal component analysis or PCA for feature extraction. Unlike feature selection, PCA doesn't just pick existing features, it creates new ones. It does this by transforming the data into new dimensions called principal components, which capture the most variation in the dataset. Before applying PCA, we standardize the data using standard scalar to make sure all features had mean of 0 and a standard deviation of 1. This step is crucial because PCA is sensitive to scale. Then we use PCA to reduce the dimensionality of our dataset. while keeping around 95% of the variance. This allowed us to simplify the data while still preserving most of the important information. This technique improved training efficiency and also helped reduce multicollinearity between features. Finally, we use the transform dataset to train and evaluate a classification model and compare its performance with the models that use feature selection.
Assalamualaikum warahmatullahi wabarakatuh. I'm Fitrana Humaira with metric number 2212822. So I will continue the presentation with the performance analysis. So for our project, for our assignment, we have decided that accuracy is one of our measure that we will use to evaluate the performance of each model that we have chosen. So for the original model, which is the random forest classification, the accuracy is 0.499. Meanwhile, for the filter method of feature selection, we have used SelectKBest and the accuracy is 0.506. And also for the feature selection technique, which is wrapper, and we have chosen RFE, the accuracy is 0.502. And the last one is for feature extraction, which is we choose to do PCA, the accuracy is 0.509. Therefore, what we can see is the highest accuracy was obtained when we classify the dataset with the feature selection filter method, which is SelectKBest, and also the PCA for feature extraction. So the reason why SelectKBest and PCA have the highest accuracy is because with feature selection technique, which is SelectKBest, they will remove irrelevant features. So in sometimes some features only add noise rather than give a useful information. Therefore, with SelectKBest, they will keep only the most important features and the most statistically significant ones. So by using only the 20 most informative features, like our example, we use k is equal to 20, the model is likely to avoid noise and overfitting from the less important ones. Next, for the PCA, PCA is a feature extraction method that transforms the data into new features, which is principal components that capture the most variance. So PCA will reduce redundancy by combining correlated features and also reducing the repetition and multicollinearity. So models that trained under PCA will transform data often perform better when original features are noisy or weakly informative. So lastly, PCA will create a cleaner, less noisy version of the dataset that will help the model focus on the more meaningful patterns. I think that is all from the performance analysis.